Okay, so let's finish up this review for the Unit 4 lecture exam for this lesson on the structure of the universe by talking about even larger structures. So that galaxies then are grouped into clusters of galaxies. I think that you ought to know that the Andromeda galaxy is part of our cluster of galaxies that the Milky Way belongs to. But you're not responsible for knowing the size of a cluster of galaxies. Okay, and then clusters of galaxies are going to be clustered into superclusters. And then those superclusters of galaxies are going to be in the cracks of bubbles. So the universe at the largest scales consists of bubbles, and then where the bubbles come together is where the superclusters of galaxies are going to be located at. And then the bubbles are going to be called cosmic voids. Now, they're called voids because there isn't that much stuff inside of them. Now, there actually is. So even inside of a cosmic void, there is some material. It's just, it's not very dense compared to the material that's in the cracks where these bubbles come together. Okay, and so you would, you should know, for example, that it takes light about 8 minutes to get to the Earth from the sun. And then you should know that, for example, it takes about 5 hours to get out to Pluto. And then it takes about 4 years to get to the closest star. But that's about it. Okay, and then we also talked about how did the universe get its structure. And so this gets into the idea of quantum mechanics. So that when you have very, very small objects, we have to use the laws of quantum mechanics in order to explain it. Now you're saying, well, how did the universe, why would we need, if the universe is so big today, why would we need to use quantum mechanics to explain the structure of the universe? It's because we think that at the moment of the Big Bang, the universe was very, very small. So one of the things about quantum mechanics is that things are very, very random, okay? And that when you have very small objects, particles can appear out of nowhere and then go back to where they came from. So there is a constant fluctuation in energy of very, very small objects. So that the early universe had these fluctuations, areas where it was more dense than other areas for just a split second. But for that split second, the universe expanded. And so those density fluctuations in the universe expanded along with the expansion of space and time. And then later, those density, areas where it was higher in density, that collected dark matter, which has mass and gravity, and then that in turn collected regular matter on top of it, and then as that matter got congregated, it started to trigger star formation. And so that's the reason why you have this kind of a bubbly appearance to the universe. Okay, so 1 down and about 6 more to go. All right, so let's take a break, and when we come back, we will start with our next review topic.